General Wave Properties, Crazy IGCSE. Welcome back to Crazy IGCSE. For those of you who are new to my channel, hi, this is Crazy IGCSE, where you can study 7 IGCSE subjects at one place. The subjects include biology, physics, English, mathematics, business, economics, and accounts. So here is IGCSE at your fingertips. Please subscribe to my channel, like this video and comment down. Now let's start the topic. Today we'll be learning waves, so let's look at the demonstration of reflection and refraction using water waves. To know more on reflection and refraction, do click on the card above to know the basics of waves. So ripple tank is an instrument which is used to study the properties of waves. So a ripple tank is an instrument and it is used to study the properties of waves. Also, you need to know that the waves can reflect, refract and diffract. We'll be learning how to draw a reflected wave, refracted and diffracted. So a wave front is the joining of the crest of each wave which will result in a line. That line is known as a wave front. This means that the line which will connect each crest of the wave will be called the wave front. Wavelength in a wave is from one wave front to another wave front. Ray is the direction of the wave and it will be the right angle to the wave front. Then the bouncing back of waves is called reflection, and when it hits a barrier, reflection occurs. So reflection is when a wave hits the barrier and it causes the bouncing back of waves. Now here is the diagram. So these waves you see, red ones, these are waves, and these blue lines, if you can see, are wave fronts. Then reflection of water waves. So the shape of the reflected wave will totally depend on that type of barrier it is reflecting on. And when a circular wave touches a straight barrier, the reflected shape will be circular. And when a straight wave touches a straight barrier, the reflected shape will be straight. So here is an example of a circular wave which touches a straight barrier. So here, if you can see, this is a straight barrier, the waves are circular, and the reflected waves are circular as well. In this one, it is straight waves which are hitting the straight barrier. So waves change their wavelength if they travel from one medium to one other in which their speed is different. And the reflecting surface is the surface where the waves bounce and reflect back. Incident ray is the ray which strikes the surface. Reflective wave is the ray which is reflecting back after the reflection process. Normal is the imaginary line which is 90 degrees to the surface, which means it is 90 degrees to the barrier, and the normal should be drawn with a dotted line, which means in this format. So this will be the normal. Then the angle of incidence is the angle between the normal and the incident ray. The angle of reflection is the angle between the normal and the reflective ray. So here is an example. Here, if you see, this is the reflecting barrier. This is the incident ray which is coming towards the barrier, and here it is bouncing back the reflected ray. So also one more thing is important when you draw these waves, that the direction should be shown. So the arrow should be shown. Here it is going to the right and reflecting. So this angle, and here the middle line over here, which is vertical, is called the normal, and it is drawn with dotted lines. And the angle between this normal and the incident ray is called the angle of incidence, and the angle between the normal and the reflected ray is called the angle of reflection. So here is an example of the proper rays drawn. So you need to first draw the barrier. After that you will have to draw the normal, which will be in middle. After that you need to draw the the incident wave fronts, the incident waves. So it should have the same measurement. So for example, this is 1 centimeter, even the remaining distances should be 1 centimeter. This part of the diagram is called the incident wave fronts, which is coming towards the barrier, and this part which is reflecting here, this is called the reflected part. So you just draw a line like this, then with the same measure, example if it's 1 centimeter, draw another line in the same direction, then in other, it will not touch the full surface like this, it will not touch the normal, that's not necessary. After that draw another line again. After that you need to draw the ray. So this is the incident ray, mark the direction. Then you can also measure the angle of incidence, that is very important. So the angle of incidence is between the normal and the incident ray. The example for example, you got 50 over here as the incident angle of incidence. With that same angle, with your protractor measure 50 degrees, and you will need to your reflected ray should be 50 degrees. Before that you could also draw the reflected wave fronts, and it should be having the same measurement as if this is 1 centimeter, then this should be 1 centimeter as well. So with that same measurement in the same direction like this, you need to draw the reflected wave fronts. So here if you need to draw a circular wave coming towards a straight barrier, then first you will have to draw the the surface, which is the barrier. This is the barrier. Then you need to put your pencil in the middle, just like over here, and then using your compass you will have to draw circles. So you can draw one circle here, then the example, this circle you have drawn with a 1 centimeter measurement, then take this as 1.5 or 2. So you need to draw it like this, and then as you keep drawing you will get circles like this. After that's done, you will have to draw the reflected wave fronts. For the reflected wave fronts, you will have to measure the distance from the barrier to the middle point. So after you mark the point, you need to find the distance between the middle point and the barrier. For example, this is 2 centimeter. With that same measurement, 2 centimeter, mark a point below the barrier. You've marked it here. After that, measure the distance from the center point above the surface to the wave fronts which touch the surface with that measurement. So keep your compass on the point below over here, and then measure the distance. Also you need to remember that you can't draw the reflected wave fronts of the circle as it's not touching the surface. You can only draw the reflected wave fronts of the circles which are touching the barrier. Okay, so then you measure the distance from this point to this incident wave front. Then you keep your compass on this point and then draw an arc. Then do the same for the remaining wave fronts. So this is how you draw for on a circular wave which hits a straight barrier. Now coming to a straight wave which hits a straight barrier. For this, First you will for this the question will already be given as the barrier here. Then your incident wave fronts will also be drawn, and these incident wave fronts will be drawn with equal distance. The distance will be equal. Then you will also be given half of the incident ray. So this is half of your incident ray. Now whatever is drawn here in pencil is what the question will be like. The ones which are in blue is what needs to be completed by the student. So the direction of travel has been drawn till here. Now this is the incident ray. You will have to complete this incident ray, so draw it up till the barrier. It needs to touch the barrier. After completing the incident ray, you should always draw the normal. The normal should be 90 degrees to the surface. After you draw the normal, measure the angle between the normal and the incident ray. Example, you get here 45. So that same measurement of 45, you need to draw the angle of reflection. After you do that, you can draw the reflected ray. So after you draw the reflected ray, you need to draw the reflected wave fronts. Now for the reflected wave fronts, your wave fronts should be perpendicular, which means 90 degrees to your reflected ray. So this means this is your reflected ray. Now to draw the wave fronts, you need to make sure that your reflected wave fronts need to be 90 degree to the reflected wave. So here if you see, when you mark 90 degree over here, it will be 90 degree. So that way it should be equal as 90 degree. And if you see this one as well, it is 90 degree. This one's also 90 degree. So that's how you need to draw the reflected wave fronts. And you need to always make sure that your reflected wave fronts are 90 degree to the reflected wave. So this is 90 degree. So this is how you do for a straight wave touching a straight barrier. Now reflection. The wavelength, frequency and speed do not change, only the direction changes. For refraction, the wavelength and speed change and the frequency does not change. Now the refracted ray undergoes a change of direction when travels from one medium to another is known as a refracted ray. So things to be careful about: the incident wave front should have equal distance. The refracted ray should be 90 degrees to the wave front. So when a refracted, if for example you're drawing a diagram for a refracted ray, and if it's going from shallow to deep water, the wave speed will increase as it goes into deep, and that's why it will bend as it moves. The refracted ray will move away from the normal. We'll see how it looks like. Then the speed and the wavelength will increase. The wavelength will increase as it goes into the deep side, and if the wavelength increases, even the speed will increase. However, the frequency will remain constant. The angle of refraction in the shallow to deep diagram will be more than the angle of incidence. And the refractive wavefronts, the distance between the wavefronts should be bigger, which means the wavelength of it should be bigger. So this is how we draw shallow water to deep water. So in this diagram, if you see, first in the question the incident ray is given as half till here. The wavefronts are already given and the barrier is also drawn. Now we need to complete this diagram. So we complete the incident ray. First thing we need to do is draw the normal, which will be 90 degrees to the surface, which means to the barrier, and then you need to mark the angle of incidence. For example, this is 45. Let me change the color. So for example, this is 45. Now you need to draw the refracted ray. For that, your refracted ray should have an angle bigger than 45. So it could be 50, 55, 60, 63, any angle which is bigger than 45. So this angle will be bigger, and as you measure it, it will move away from the normal. So you will see that the ray will be moving away from the normal. It is not towards the normal. It is not towards the normal, it is going away from the normal. And then you need to draw the refracted wave fronts. Now for the wave fronts, the wavefront should always be perpendicular to the refracted ray. So make sure the wavefronts are 90 degrees. So here, so now when you see, this is 90 degree, this is 90 degree, 90 degrees. So it should be equal. And another thing to remember is, here if you look at the wavelength, so the wavelength over here may be 1 centimeter, but if you go to see the wavelength over here, it is much larger. It could be 2 centimeter. So you need to make sure in shallow to deep water, you need to draw the refracted wavefronts larger, which means the wavelength should be larger than the incident wavefronts. Now deep to shallow, if the refracted ray moves towards the normal, the speed and the wavelength decreases and the frequency remains constant. The angle of incident will be bigger than the angle of refraction, and the refracted wavefronts will be smaller, which means the wavelength will be smaller than the incident wavefronts. So here is an example. So here, this is the barrier. Your incident wavefront is over here, and this is the incident ray, and your incident wavefronts will be here, and the wavefront should have equal distance. After that, you need to complete a diagram. For that, first draw the normal, which will be the dotted line. That will be the main step after completing or drawing the incident ray. After that, you need to draw the refracted ray. Before that, we will mark the angle between the normal and the incident ray, which will mean the angle of incidence. For example, this is 60 degrees, then your refracted angle of refraction, which should be smaller than the angle of incidence. So it could be anything below 60. It could be 50, 45, any amount, any number below 60. So for example, you drew 45 degrees, then you need to mark your refracted ray. So to draw the refracted wavefronts, your wavefront should be perpendicular to your refracted ray. Now in this diagram, it is not drawn perpendicular, but it needs to be drawn perpendicular. So it will be like this. So here will be the refracted wavefronts, and the refracted wavefronts, their wavelength should be smaller than the wavefront of the wavelength of the incident wavefront. For example, this is 2, so this one should be only 1. So like that we'll have to draw, and remember again that your refracted and reflected wavefronts should be 90 degrees always to the refracted or reflected ray. Now why do water waves travel slowly in shallow water than deep water? Because the wavelength is small, which means the distance is less. Since the wavelength is small, the speed will also decrease, and the angle of refraction is less than the angle of incidence. Thank you for watching Crazy IGCSE. Please subscribe, like, share and comment.